As far as humanity knows, there is only one confirmed living world in the entire universe: Earth. One small planet orbiting an ordinary star in a quiet corner of the Milky Way. For generations, we searched for another place like it. We explored Mars hoping to find traces of ancient water. We studied Venus beneath its toxic clouds. We looked toward Europa's frozen ocean hidden under ice. We examined Titan's strange methane lakes and orange skies. And through all of it, one question refused to disappear. Are we alone? Then NASA launched a telescope designed to answer that question in a way no mission before it ever could. Not by searching for aliens directly, but by hunting for worlds. Real planets orbiting distant stars across the galaxy. In 2009, NASA launched the Kepler Space Telescope with one of the most ambitious scientific goals ever attempted: find Earth-like planets beyond our solar system. At first, the task sounded almost impossible. Planets are tiny compared to stars. They do not shine brightly on their own. Across interstellar distances, most of them are completely invisible. So Kepler used an incredibly delicate method. It stared continuously at more than 500,000 stars, searching for tiny drops in brightness. If a planet passed in front of its star, the star would dim ever so slightly for a brief moment. That tiny flicker was enough to reveal an entire hidden world. The challenge was enormous. If Earth crossed in front of the Sun from far away, the brightness change would be microscopic. Almost nothing. Yet Kepler was sensitive enough to detect those changes across vast regions of the galaxy. And what it found changed astronomy forever. Over the course of its mission, Kepler confirmed more than 2,600 exoplanets and identified thousands of additional candidates. But the real surprise was not simply the number of planets. It was their diversity. The galaxy turned out to be far stranger than scientists expected. There were giant gas worlds orbiting dangerously close to their stars, so hot their atmospheres glowed. Massive rocky super-Earths larger than our planet but smaller than Neptune. Worlds covered in lava oceans. Planets orbiting two stars at once like something from science fiction. Kepler revealed that planetary systems can form in ways humanity had barely imagined. But buried among all the strange discoveries was something far more important. Worlds that looked possible. Planets sitting in regions where temperatures might allow liquid water to exist. Worlds that made scientists stop and ask the most unsettling question in astronomy. Could life exist there? The most exciting discoveries were not always the largest planets. They were the planets orbiting inside what scientists call the habitable zone. The narrow region around a star where conditions may allow water to remain liquid on a planet's surface. Not too hot. Not too cold. The cosmic Goldilocks zone. And slowly, Kepler began finding Earth-sized planets inside those regions. That was the moment everything changed. One of the most famous examples became Kepler 186f. Discovered in 2014, it immediately captured global attention because it was remarkably close to Earth in size and orbited within the habitable zone of its star. Scientists later suggested its climate stability and orbital behavior could potentially allow long-term environmental balance. That detail mattered enormously. Because habitability is not only about distance from a star. A planet also needs stability. A world can sit in the perfect zone and still become a frozen wasteland or a burning nightmare. But if atmosphere, orbit, temperature, and rotation all work together, the possibility of life becomes much more realistic. Then came Kepler 1649c. A planet discovered later through reanalysis of older Kepler data. What shocked researchers was how eerily Earth-like it appeared in the numbers that matter most. It is only slightly larger than Earth and receives roughly 3/4 of the starlight our planet gets from the Sun. That means, with the right atmosphere, its surface temperatures could potentially resemble conditions on Earth. Not identical, but close enough to ignite imaginations around the world. Then there was the discovery that truly felt like 7 rocky Earth-sized planets orbiting a small red dwarf star. 3 of them located inside the habitable zone. Imagine standing on one of those planets and seeing neighboring worlds hanging enormous in the sky above you. Entire planets visible like giant moons. The system is also older than Earth, meaning life there, if it exists, may have had billions of extra years to evolve. That possibility is difficult to even comprehend. And of course, there was Kepler 452b, the planet many people nicknamed Earth 2.0. It orbits a Sun-like star and takes roughly 384 days to complete a year. Its similarities to Earth immediately captured public imagination. The planet itself is larger and heavier than our world, meaning gravity there would feel stronger, but it was close enough in character to make the dream suddenly feel real. For the first time in history, humanity was no longer imagining hypothetical second Earths in abstract terms. These worlds had names, distances, atmospheres, orbital periods. They became real places in the scientific map of the galaxy. But perhaps Kepler's greatest achievement was not any individual discovery. It was the statistics. Before Kepler, Earth-like planets were mostly speculation. After Kepler, astronomers realized they might actually be common. Data from the mission suggested that roughly 1 out of every 5 Sun-like stars may host an Earth-sized planet in or near the habitable zone. Think about what that means. The Milky Way contains hundreds of billions of stars. That could translate into billions of potentially habitable worlds in our galaxy alone. Billions. That realization changed the emotional scale of the universe forever. Because once the number becomes that large, space no longer feels empty. It feels distant. The silence of the cosmos begins to feel less like absence and more like separation. The challenge may not be that life is rare. The challenge may simply be that the universe is unimaginably vast. Kepler retired in 2018 after running out of fuel. NASA sent the telescope one final message before it drifted permanently into silence. But by then, its mission had already transformed humanity's understanding of existence. Earth-like planets were no longer fantasy. They became part of the architecture of the galaxy itself. And now, newer observatories like the James Webb Space Telescope are continuing that search, studying atmospheres, chemistry, and perhaps one day even biosignatures that could hint at life. But the story grows even stranger. Scientists are no longer searching only for planets exactly like Earth. Some researchers believe there may be worlds even better suited for life than our own. Planets with slightly stronger gravity capable of holding thicker atmospheres. Worlds orbiting long-lived orange dwarf stars instead of stars like our Sun. Places with more stable climates and far longer windows for evolution to unfold. That possibility changes the question again. The dream is no longer simply, find another Earth. Now it is, could the galaxy contain worlds where life had an even better chance than it did here? One fascinating example is KOI 5715.01, a rocky super-Earth orbiting within the habitable zone of an orange dwarf star. Orange dwarf stars may represent some of the best environments for long-term habitability. They live much longer than stars like our Sun while avoiding many of the violent radiation eruptions associated with smaller red dwarfs. A world orbiting such a star could potentially enjoy stable conditions for tens of billions of years. Enough time for evolution to explore possibilities far beyond what happened on Earth. That thought is almost overwhelming. Life on Earth needed billions of years to become what it is today. What could happen on a planet given 10 times longer? And this is where Kepler's discoveries become deeply emotional. Because once humanity accepts that Earth-like planets may be common, and that some worlds may even offer better conditions for life than Earth itself, then humanity's place in the universe begins to feel different. Earth stops looking unique. It starts looking like one example among countless possibilities. But there is also something haunting about this realization. Most of these worlds are impossibly far away. Dozens, hundreds, thousands of light years distant. We can detect them, measure them, study their atmospheres, dream about their skies. But we cannot reach them. Not yet. That creates a strange tension in modern astronomy. The universe no longer feels empty. But it still feels unreachable. In some ways, that makes these discoveries even more powerful. These planets are not destinations. They are provocations. They force humanity to imagine worlds it may never touch. At least not for a very long time. And that is why Kepler changed everything. It transformed exoplanets from speculation into population. It turned Earth-like worlds from fantasy into statistics. And in doing so, it left humanity with one of the most beautiful and unsettling truths ever discovered. The galaxy may be filled with second Earths. Maybe even better Earths. Worlds with oceans, weather, mountains, clouds, and perhaps life already unfolding beneath